My qualm with the way that people have approached this is that for existing vendors, and of course this is no fault of theirs, but it all feels very horseless carriages, right? I think people have pointed this out before, that it all feels like you took a chatbot and...
Welcome to episode 3 of Agentic Data. We've been away for a while because I had COVID. I got knocked out, still recovering, but hopefully we could do this in a reasonable cadence going forward.
It's good to have you back, Joseph.
In the interim, we had a lot to think about. You wrote some good content. I produced some good content. We thought a lot about what we are doing in a more philosophical way. So that was fun. We got to think about the industry as a whole and also how these lessons apply to the broader state of things, right? So that's been interesting. And on that note, Robert, you recently wrote a post on Agentic Data, our Substack, about Skeuomorphic AI and why this is not a great way to think about how to build AI agents or AI systems. Can you tell us more about that post and what that means to you?
Yeah, for sure. I think back in 2023, 2024, it started to become increasingly obvious to everybody in the data world that they had to pivot and lean into the AI stuff. The qualm that I have is that the way that people have approached this, and yeah, this is the article. Thanks for showing it, Joseph. My qualm with the way that people have approached this is that for existing vendors, and of course this is no fault of theirs, but it all feels very horseless carriages, right? I think people have pointed this out before, that it all feels like you took a chatbot and you just attached it to your existing tool and you hoped that this would basically be like an AI native tool now. Lately, more and more, it feels like we've gotten into this weird local optima where we started with that and we started with existing systems, and now we're like slowly trying to converge through the gradient descent into something that starts with this initial pattern but feels better than, you know, the AI glued to the existing product pattern. And so I really, my qualm here was that we're not doing this from first principles, right? When there's such a massive paradigm shift, you have to rebuild everything from the ground up, and you have to be very intellectually honest about what you're trying to accomplish, how you're trying to integrate these tools together, or how you're trying to use AI to really overhaul existing patterns of behavior. I think I drew the analogy in this article, but I think it all feels very much Blockbuster pre-Netflix, right? Where Blockbuster was very store-centric, and in the same way, the entire data stack is very like modern data stack centric. And it's hard for people to, it's hard for us too, right? Joseph, we spend a lot of time thinking about this and agonizing over it because our brains are just so mired in the past. But it's like it was very hard for Blockbuster to see a world without physical stores. Like even their video rentals, their online video rentals, when they had them, if I remember correctly, were tethered to the store in some way. And I think in the same way, we have AI systems that are tied to the existing modern data stack in a very tack-on, glued-on kind of way. Yeah, that's roughly the gist of it. Do you have any thoughts on this, Joseph?
That makes sense. Are there more specific points that you want to point out in terms of what are the benefits of thinking from first principles and being the Netflix, not the Blockbuster? Like, it's easy to point out that this is the case, but it's much harder to, come up with specific examples in which why this is bad. Like, it's a bad mode of thinking. Of course, I mean, you could argue that that's what happened to Blockbuster and that's why they failed. But like specifically what thinking in this new paradigm might get you. And then segue into the second piece, which is more about then what is our solution to this, or what is your solution to how we should move forward?
Yeah, it's funny because like you can draw this analogy between Blockbuster and Netflix, but right now it feels like no one, maybe except for us, is like trying to be Netflix. The qualm that I have with a lot of the existing new vendors, like the startups, which I've mentioned here, is that there's like this weird laziness that's become very pervasive in the AI startup world, where I think is largely like AI is going to solve the problems that we have right now. But I think right now the issues, the problems are largely from AI. So like people are thinking basically like AI is going to solve the problems with AI, which might be true when we get to the singularity. But all right, I'm digressing a little bit. I think this is all just to say that I think it's really hard. It's not as trivial as you would think to get to the Netflix world. And one of the things that I think, Joseph, you could talk a little bit about more is early on, we made this decision to create our entire system such that it would be centered around YAML. And I know that there were a lot of memes going around YAML like in 2023, but I think there's something quite significant about this. It's not just, okay, yeah, you get configuration as code. It's a way to version control, GUI changes and things like that. I think there's something a little bit more profound. And Joseph, I remember you had a really nice point about this. Would you call it headless software? Do you want to talk a bit more about that?
Yeah. And so, okay, our point of view, our answer to to everybody is thinking about this situation in a more naive way, and we want to be less naive about this. Like, our answer to that is that I think in general, what we are doing and what one should do in this new era of AI, if you are an enterprise software builder, is that we need to stop thinking about this entire system as software. I think previously we had this wave of software going from on-prem software to web-based software, and that was pretty much what the past 15 years was about. And software is about automating certain processes using GUI components and CRUD operations in the back end, reductively what that system of record is really doing. And sometimes things are closer to infrastructure, like database companies, data warehouse companies, and so forth. But application companies are CRUD applications. It's automating things using GUI components and actions that get triggered by things users do in the GUI. So that's like how one thinks about enterprise software. But I think where we are headed is something very different, where not only are you building AI agents, which I believe should be classified as their own objects, AI agents, but what we want to call headless software. And I think we're going towards a world in which we build what we want to call agentic software, which is a hybrid between AI agents and headless software. And what we mean by headless software is that traditionally software was designed so that humans could use the software and then make changes to the underlying database and perform actions on that software. Headless software is software that is built and tools that are built, software and tools that are built for AI agents to use. And AI agents don't have the same limitations that a human does. Like, they don't need to use a GUI per se. They could just interact with APIs or protocols like MCP. And so I think not having that really clunky GUI part allows the agent to really use the tools in a much more effective way that is really tailored to the agent's strengths. And I think in some sense, as humans, we're sort of rate limited by the interface that we use, because it would be great if our brains could just connect to a computer and then just our brain waves just like manipulate things. And then we don't even need to visualize it on the screen, that literally the information just gets beamed back into your brain. Okay, that's like probably like the best interface there is, but we don't get to do that, right? So that's why you have to use a keyboard and a mouse, and you got to look at display. It's the same concept. An agent should not go through this chokehold, like this bottleneck of using an interface that we have developed for humans. It doesn't make any fucking sense. So what should happen is we should develop new interfaces for the agent to use so that the agent could be a lot more productive. So from that perspective, this hybrid of like, hey, AI agents are sort of now this object that a human gets to interface with. You can communicate with the agent execute tasks, it understands information, even orchestrates pretty much everything. It could orchestrate with other agents, like you could talk to other agents and come up with complex multi-step processes. It could run workflows and sort of things like that. And that if a step in the workflow fails, then you re-execute that part of the workflow, et cetera, et cetera. So that AI agent becomes sort of this new interface in which humans and agents interact with. And then these agents get to use headless software. So that's like the super high level of where we think enterprise software is going. We're going from enterprise software to the world of agentic software, which is, again, it's a hybrid of AI agents and headless software. So that's our standpoint. And of course, this applies to data analytics at large as well. And I think what we've been thinking about, and like some folks have expressed similar sentiments, but I think in the past few decades, we as a community have built data tools for humans. This is very obvious. And we have made certain trade-offs. And the trade-offs could be best articulated if you if you think about the application layer of the data stack, meaning BI tools and product analytics tools and notebook tools, anything that a human gets to use on the application side of using data. All those companies and all those vendors and all those products are generally focused on building a very, very, very good GUI wrapper so that a human could use the GUI to manipulate the data. Of course, there are other examples like notebooks wherein you get to write some Python and SQL code. But the truth of the matter is because there are only millions of people in the world who know how to use SQL and Python proficiently to do any sort of non-trivial data analytics. So you can't build a system at scale that is very, very code-centric. So then most of the tooling, like Power BI and Tableau, they have to be based on GUI, which literally everybody knows how to use. So that's what happened. And now, if you think that is enough in this new world, I think folks are gravely mistaken. I think an even better interface on the data application side of things is a natural language interface, which this part I think a lot of folks agree on. But what is different in our assertion is that you have to re-architect the headless software piece for the AI agent to use. You can't be Power BI or Tableau, which is a completely GUI-centric interface, and then add on top of that a bunch of AI agents running around. It's going to work less well than a system that is built from the ground up, knowing that all of your software components are just going to be used by AI agents. So you don't have to have any like GUI drag and drop builder. You don't need to focus on things that could be done with the mouse and things like that. And what happens is the great advantage of that is that you now get to actually have a massive surface area of things that you could actually do with the platform now. Things were constrained before by the GUI, but no longer are things constrained by what the GUI could do. You literally could do 10, 100, 1,000x more things than you could do before. And the interface is even easier than a GUI, which is through just natural language, right? Because of this, I think the incumbents have a massive disadvantage in building agentic software, because if you add on the AI agents, then you're necessarily gated by the GUI components. So it's kind of like saying everything that you get to see in this world is going to be through like your laptop screen. Like everything that you get to absolutely observe is going to be rate limited by the laptop screen. But then we're saying no, that rate limiting step is no longer there. You just take out the screen and then you just observe the world by yourself. That's sort of like a profound change. And that's why I think we deserve to exist. And I think as an agentic analytics provider, and then I think this is why a lot of startups get to exist now, like every single system of record. I mean, folks have been saying that you could use the AI agents as a Trojan horse and then like use that to really redefine the system of record. But I think we could be even more precise than that. I think that the next system of record layers will be generally headless. And so that's like our contribution to this argument here.
A lot of things to riff off there, but I feel like from that paradigm, GUI was necessary because humans require visual feedback and design, explore, and iterate on the fundamental thing that you're creating, right? And of course, like any system that's optimized for being conducive to that pattern of interaction isn't going to be, unless you are very intentional, maybe like the more BI as code world, but unless you're very intentional, it's not going to translate very well into something that's like machine code or something that can be very easily like the pure logic that LLMs reason best against. What's interesting to me about this is, and I think we didn't quite get there yet, is like another advantage of this divorced configuration from the GUI world is that, systems that traditionally use these YAML files as like these code as configuration paradigms like Terraform or Kubernetes, like the best thing about them, and the software engineering world knows this already, is that like Kubernetes doesn't really care if you're on like EKS, or practically speaking it does, but like generally you don't really care if you're on like EKS or GKE or whatever, or like a bare metals Kubernetes cluster. Like Terraform is the same way. It doesn't really matter what like cloud provider you're using under the hood, to an extent, of course. Like GitHub Actions, the same thing. But like this world, what's interesting is like this world hasn't really taken other domains by storm. Like engineers understand this very viscerally because they're like, oh, we built something. I wrote all this code. I don't want to have to write it again for a different system. So the industry pushed them towards that. But what's really nice about this is I think AI incentivizing the world towards headless software, which is really what this like YAML configuration world is. And then as a result, we're going to get hopefully much more widespread standards that can be used with any sort of tool underneath, right? Like the engine can be split from the specification, as you like to say, Joseph.
Yeah, this is true. I think what we think is that in the age of headless software, the interface in which agents will interact with the headless software is going to be through a declarative interface. And one canonical way of representing declarative interface is through YAML, right? Either YAML or TOML, or like there's a few well-accepted standards, but YAML is so simple, right? So it makes a lot of sense when I say, hey, system, or hey, agent, could you do this following task? Go to my database and look up these numbers and information and then synthesize against this in the following manner, XYZ. That instruction set could then be translated into this declarative interface. Yep. Then that could be translated through a runtime and actually get executed. Yep. And that translational layer between the English and actually things being executed. This is the research that we're doing, and we call this the latent deterministic scaffolding research that we're doing, right? So
paper coming soon.
This is all coming together. And I think this latent deterministic scaffolding idea is not just about data analytics. It should be about everything in agentic software, but it really, really is important for domains that are very precision specific. We've now been using these phrases, precision recall in machine learning. There's this notion of precision recall. Recall is about how many things I'm able to actually label correctly, like reductively speaking. And then precision is like basically how precise am I about how eager I am about actually labeling this thing 1 instead of 0. One could think about, I'm going to look at dogs and cats, and then you could have like a classifier that says like everything is a dog. Like it's like a constant classifier. It's like way too eager to classify everything as dogs, but super low precision, 100% recall, because you could recall all the dogs, right? That's the lingo, machine learning lingo. And for almost all of unstructured AI, if you're Perplexity or even if you're like a code gen AI, then you could actually have lower precision and you will live. Like if you're on Perplexity and then we ask a question like, what is the best data streaming engine? Give me like top 5 and then give me some examples of this and reasons why I should pick this. And it'll give you some information. If like one sentence is like a little bit wrong, like the word choices are slightly wrong, okay, you're gonna live. Like it's still super useful to do this. But if you're in a field like data or accounting or finance or maybe law, you're gonna get into trouble if you don't have high enough precision. For example, like accounting is a very good example that we like to tell because it's very visceral and intuitive. If you calculate the wrong revenue numbers for your quarterly investor updates as a public company, you're gonna get fucked. The number is just wrong. Like, what are you gonna say? It requires extremely and insanely high precision. And then, of course, there are not that many metrics that folks care about in a business from an official public accounting perspective. So, of course, it's like low recall. Like, you don't have to get everything perfect. You just need to get these like 10 metrics perfectly. And so that's what we mean by a high precision, low recall system. And that's what data analytics is. It's a higher precision. It must be pretty much 100% precise, but lower recall in the sense of like, it is okay to not be able to answer all questions, but among the questions that you answer, it must be insanely correct. And that's like sort of the system that we're building towards. I think the latent deterministic scaffolding idea is very, very important for those domains.
I don't know if you remember this, Joseph, but we had this interesting conversation earlier this week where we were talking about the analogy to machine learning, being a little bit more specific about precision recall. I remember I shared like a potential breakthrough we may have had is that what matters also as a parameter in this is like the cardinality of the solution space. For context for everybody else, we've been trying to figure out how to do deep research in a really good way, robust way within our product. And what's really interesting about that is that traditionally, for most analytics questions, you have very high precision requirements, but then sometimes you don't as much. And characterizing like what's the nature of the precision that's required in those instances is much less clear. But I think the conclusion that we got to was something like in these, sometimes there's a single, and in most of analytics, there's usually like a single answer to a question, right? It's like, how many users visited the site yesterday? That's just a number, and that number just can't be wrong. But then on the other hand, as you get slightly more ambiguous or you have a slightly less concrete sense of precisely what metric you want, and you want something like, build me a report on the possible causes of our metric drop yesterday, it becomes much more flexible. And so like, then there's this other world of, okay, we need to just, I don't know, I mean, we still need to figure this out, but we have like both a different means of evaluating that world, as well as a different means of approaching what the algorithm looks like, right?
I think what we want to do is we want to have a taxonomy of the question space. There are two things to think about. There's like the question space, which is like all the things that I'm asking the computer to do in agentic data analytics. Ask simple questions about what happened here historically. And then for things like deep research, it's really asking about why this happened or how this happened or like figure it out. Like basically do this more freeform thing. these are two separate spaces in the domain, in the sort of the question space. And then question space obviously maps onto the answer space, and the answer space has some properties and some statistical properties of how you get there. And I think it is very helpful to classify, just pull it all the way back, because we want the engine that maps the answer space to the question space to the answer space to be as surjective as possible, or basically 100% surjective, meaning it's going to be able to answer everything. Then, of course, you could pull it back into the question space, and then just try to understand the questions, and then these will all map to the answer space, right? And from that perspective, I think a very reductive but helpful thing to start off with is the fact that the what questions, what is this metric, or even who and when, these like very precise questions need to have high precision, absolutely high precision. But these questions, relatively speaking, take up less space in the answer space, meaning it's a low cardinality type of situation. And then you have high cardinality, which takes up a lot of space in the answer space, which are sort of the why and the how questions. And those questions could be answered in a slightly less precise way with a higher recall situation. So even knowing that difference is really helpful. I think, generally speaking, the language of data analytics is very different from the language of machine learning and AI. And I think we need to combine these together. And literally, like, we just don't hear folks thinking about things in a rigorous enough way to think about precision and recall. And these are just like, you just take one class in machine learning and that's like what you learn, right? It's not even the most complex thing, but I think that's sorely lacking. And I think it's because we're in this intersection domain between data analytics and data science and machine learning. And in the intersection domains, it's really hard to unify certain concepts together. And in some sense, that's what we're good at. And that's what we're doing is really combining these two domains together, just because, Robert, you and I have experience at doing both, right? Like doing the machine learning and AI engineering, as well as doing data science and analytics. So I think that puts us in a pretty interesting position to do that. But I think understanding what we're actually building from a mathematical perspective and having some good taxonomies of things, and then understanding the statistical properties of the cuts of the question space and the answer space, super helpful. I haven't seen anybody think about it from this perspective yet.
Yeah, for sure. I think I'd mentioned this to you, Joseph, but like fundamentally what we're doing here, it's weird because it's a cross-discipline in a very strange way where like we're actually applying machine learning principles to the building of the software around AI, not the AI itself, right? In that we're like using these terms like precision and recall. I mean, fundamentally what you're doing with this like taxonomy thing is actually like defining a feature set that's going to be nicely representative of some sort of structure within the prompt world, such that we can construct an algorithm that optimizes against the precision or recall that we need to optimize against.
Yeah.
There's this, and so it is like very weirdly cross-discipline here.
Yeah. So I guess precision recall these concepts have never been incorporated into the software. Generally, when you buy software, enterprise software, you don't think about precision recall of the software system. But I guess what you're implying is that people should think about it. Like that should be literally native.
Especially with AI. Everyone talks about like evaluating LLMs, and like I think the state of the art is basically like, oh, like does this have the right tone? Does this have exactly the right answer by like string matching, right? Let's just check that this answer or if it is factually correct. But like I think there's a lot more than just that, especially when you're dealing with different varying cardinalities of the solution space or what have you, right? Like SQL generation, whatever. There's a lot more characterization that can happen in terms of what does it mean for an LLM to be accurate or correct?
Yeah, it's an interesting problem because a lot of folks thinking about evaluations, basically all of them are thinking about evaluations as sort of like this observability problem where you just take all the logs and then you try to analyze them and so on and so forth, right? And then it's exacerbated by the fact that deep learning based systems are very hard to interpret, at least if you're training traditional regression models or like boosted trees and decision trees and things like that. You have statistical parameters, so you could try to understand things from like feature importance. You could try to understand some of the information characteristics of that, entropy and other things. You could study statistical properties of that, right? I think the issue with LLM-based systems is that, first of all, even if one wanted to do that, there is not really like a really good way of doing that. Trying to understand like reduced properties, like meaning some abstractions that help you really understand the system in a much better way. There is no grand theory of why neural networks are working, right? It's just like using electricity without having understood the laws of electromagnetism, which by the way, it was the case, right? Like when the light bulb was invented, nobody fucking knew electromagnetism. So it's like in the course of history, always like things get invented and then the physical laws kind of follow. So I would imagine that this is going to happen soon, right? And like statistics was one way to understand things, but it may not be enough. So like we don't even have the vocabulary to describe what the hell is happening internally within the systems, which makes the evaluations hard. And like, I think this is not an observability problem. This is an observability plus statistical observability problem. It has to be like an engineering observability and a statistical observability. And nobody's thinking about it that way. And I think what we're saying implicitly is like precision recall, these things like some amount of statistical observability and statistical concepts should be applied here to make the system better. And it's such a fucking obvious concept. And let's all get our shit together, guys.
I remember in machine learning, something that always bothered me, like even the machine learning people didn't get this, but depending on what your data set is that you're evaluating on, like your evaluation metrics change, right? If there's bias in your data set, if you built a model to categorize like how well someone's going to perform in a sport, you have trained your data on like people that run, it's not going to necessarily translate that well to people that play football. But like, I haven't heard once anybody point out, everyone's making fucking benchmarks all over the place, but like there's no characterization of the benchmark that explains like what the inherent bias is in that benchmark as it pertains to like comparison to like actual enterprise data.
The most egregious example is like, come on guys, like stop doing these text-to-SQL benchmarks because they don't mean anything. Like it's just, okay, there are a few things, but first of all, it's just categorically different from a database benchmark. At least that's very reproducible. Like if you're looking at OLAP database benchmarks, then you could like kind of compare the speed of these analytical queries against different query engines and look at the speed depending on the type of queries that you're performing. It's more standardized, it's more deterministic. Okay, fine, fair, whatever. Yeah, but that's at the same time people do hack these things. So but having it is better than nothing. But the issue is that nobody has we haven't either. So not criticizing anybody here, but we're trying to do this. We have to come up with a much better way of measuring statistical parameters of the benchmarks that are reproducible across different systems and also is like realistic. It's not about creating SQL queries and like making sure that they're accurate or something. And also like evaluating against, I don't know, like create statements and like other DDL statements that don't really matter in practice. I think that's where the academic research and reality diverges. And this is a problem, right? And so there are many things that we have to tackle as an industry. And adding some statistical notions and measurements in what we're trying to do is going to be quite important. And then I think refactoring like GUI-based software into headless software, this is going to be quite important as well. And if we just say it, I guess it's like, if you just say it, it sounds super trivial. Like, obviously, we have to refactor into more like headless software. Obviously, we have to introduce things in a more statistical way. But I just worry that nobody's actually saying the obvious things. And you and I know, right? Like, there's some problems that happen if nobody's saying the obvious things of like, why aren't people thinking about this? Which is like literally the first thing that you should think about. I think also it's just that, and you talked about this, right? And we were doing this internally, which is in this new age of agentic software, I don't think it's enough to run this factory-based software model where software is just built based on specifications. I think software is going to become more probabilistic. So from that perspective, like how we do things have to be very different. And I think because the narrative right now is so dominated by large companies like Snowflake and Databricks and so forth, who are pretty used to the old way of building software. So the output from those marketing messages is just kind of polluting things. And of course, it's not that these companies are run by well-meaning people. And then these like the agentic components, of course, is top of mind for the company, but it's actually being built and thought of by like a few PMs in the company, right? And like the question is like, do folks actually care that much? And I think my answer would be people should care even more about this shift than people are caring right now. And so that's the worry. And that's where kind of we fit in and we want to care a lot. Just think about this like 24/7.
You mentioned the light bulb. It's like people are using light bulbs and we need a unified theory of light. But like, of course, it's like much easier to use a light bulb than it is to understand how like state transitions work and how like electron midfold. Like you can't, there's a lot of work through it. But this is also like much simpler than light.
In some sense, easier to understand than light, but in some other sense, it might be sort of more profoundly different. So I'm not sure. We do talk about the fact that maybe through deep learning, like categorizing what's actually happening inside of the deep neural net might lead us to some abstract notion of consciousness. So from that perspective, like, okay, it's actually might be more profound than like understanding photons, but who knows?
Even just beyond, and I'm getting sniped, but even beyond the like questions of, oh, are neural nets representing some sort of system of consciousness? Like beyond that, it's just how can one define there's just this paradox of like, how can one define, it's the hard problem, right? How can one define a like subjective existence when there are no physical properties that seem to indicate why it should exist?
Yeah. And then, as a mathematician, my answer to you is like, it's probably all patterns, like literally just patterns, like the abstract patterns dictate everything. It seems to be that is the case in the sense of you have a biological neural net that you have neurons and you have neurotransmitters that are ions. It's basically electrical signals that are happening in your brains gated by neurotransmitters. Somehow, that's a very, very different physical system than like a silicon-based neural network system. But somehow, like you take the same pattern and make it into this new system, and somehow kind of works like in a very similar way. So you're like, okay, what do you learn from that? It's like the unreasonable effectiveness of math, because there is an unreasonable effectiveness of certain patterns in the universe, and that's how I think of it and how we talked about it. One thing that we're internally thinking about and also trying to use to persuade others in terms of why the stuff that we're doing now and other folks are doing in agentic software is profoundly different is I think that there are some physical analogies, physics-based analogies here on going from software to agentic software, in the sense of when you're describing a physical system, you might have a model to describe something like using Newtonian mechanics. But if things become sufficiently more complex, you need to have more degrees of freedom and explaining away that physical phenomenon. And then from that perspective, you need to parameterize the space better. And then from that parameterization arises, generally speaking, like a new theory of understanding things. You want to talk about that a bit?
Yeah, and honestly, I think this kind of comes back to your GUI point. But basically, I think we're so used to Newtonian mechanics, as in like we're used to the old mode of operation where like humans are bottlenecking the interaction space. And as a result, like we have Newtonian mechanics and we're trying to build up statistical mechanics from that, but it's impossible.
Could you tell us about the three-body problem and like how that motivates statistical mechanics in atoms?
Yeah. You guys have, okay, and so I won't get into the specifics of the three-body problem. Have you guys seen the three-body problem on Netflix? But basically, there's three planets, and they're all moving around, and like you end up with this like chaotic system where you can't predict where anything is going to be. Like, so you can't predict.
You literally cannot analytically write this down, right?
Building out a system that starts with just how do these planets move will never lead you to understand a system where you're like, how do 1,000, 100,000 of these systems in aggregate move together?
So enter this really helpful object called statistics and statistical distributions.
In statistical mechanics, you as a result derive more high-level derivative properties, right? Everyone's familiar with heat or temperature or like thermal energy, right? These are all abstractions that sit on top of, I guess, the Newtonian description of the world, and they end up being substantially more useful to describe what happens when you have a cloud of gas and you heat it up, or like you compress it or something. Like,
and this is because it's like analytically very difficult to precisely describe the system. It's like very similar to the fact that imagine in a deep neural net and like you're producing like a result and like you literally have like billions of parameters and you have billions of nodes, and you can't possibly try to explain away, I don't know, even 16 billion choose 2 combinations of all the things that are going on. It's like very hard to understand. It's like you need a better abstraction. Physicists come up with like energy and heat, and in physical systems, like you need better abstractions to understand things in a more intuitive way that is a more abstracted away.
Yeah, I can see like the hand wavy analogy but I feel like the problem comes down to like words. It's like words that new phase space. Like it's not so much like the neurons, but just the fact that like now we have this like very high degree of freedom system, which is like human vocabulary, which can move in any direction and also has like very ambiguous measurements in any of those directions. That's not what you were thinking, but
Oh, no. I was making a very stupid analogy, like a visual analogy, but this actually physical analogy makes a lot of sense. Like it's kind of like we're trying to understand. So there's an entire physical system composed of like human language-based semantic. Like there's a semantic space, which I think there's there's some research being done to indicate that there might be like a universal semantic space that like pretty much every trained model gets to. It all converges into the same like semantic space. So let us assume that there is a universal semantic space out there that's composed of human language, namely English, or it could be other languages, but namely English. And it's sort of like has this topological structure to it. there's some laws of physics that govern that space. Like there's like, oh, this is actually very related to the grammar thing that you talked about before, right? The grammar is like one such physical like constriction on the space, right? Like restriction on the space. And there's other laws of physics, like syntactically things have to make sense. You could like group them together. So there's some level of like group action that happens in that space. There's some binary operator in that space that could be defined. So there are all these types of things. And of course, like one could try to analytically study this system and try to do things. And that's what the fucking like NLP people try to do before, which is, oh, I don't know, I'm nuance communications and I'm just going to make some export system thing and then maybe make some Markov chain based thing. And then like basically didn't work. And all these companies that try to base their research on top of that, Alexa from Amazon, they didn't work. But then we're like, nah, let's like not do this analytical thing. Let's do this thing where we fit a gigantic neural network to learn the physical parameters of the space. And it learned the physical parameters in the sense of we could predict like how things will happen now in this space. That's from that perspective, we actually trained a deep neural net to implicitly learn the physics of the space.
Yeah, that's super interesting.
What happened? Yeah,
that's super interesting.
But anyways, that's just like a separate point from
drawing the analogy all together. Like in the same way we learned different parameters in that space, also in the word space and the products that are emitted, we obviously should be dealing with different parameters. Like we need to define entropy, we need to define energy, we need to define other shit. And so of course we need different systems to do that. There's probably even more interesting emergent phenomenon that comes out of the words that we aren't even thinking about right now. Gas has phase transitions, right? I don't know what the fuck a phase transition in semantic space would be. There's something.
Oh yeah, that's a really good point. Yeah, and in the same way, the system could have states, as in you have a complex enough system that does all of data analytics, let's say, and then certain instructions produce certain actions that are mapped to different states. Like this state is about now things got solidified and now it became like an analytics artifact. Like that is a state, like it got solidified, literally like it's in solid, right? And then something like that, right? Like and then what's statistical, like you know how like there's some physical parameters that define what a solid is, right? Like very specifically, very precisely. It's not about the temperature. Temperature definitely has something to do with it. But it's about including temperature, certain properties that happen to make this a solid and not a liquid. And from that same perspective, are there like statistical and physical parameterizations of that LLM state space that we could actually pinpoint it to be, this is like the analytical like consolidation of it into an artifact. Like that is like in this model, this is like not unquestionable that this is like the artifact now.
Yeah, that's right. And I think that's where like a lot of your taxonomy stuff fits in. Like Nick, for people who don't know, like Nick Reshednikov is someone on our team, but he also was a physicist, went to school with me back at Harvard. But I remember he brought up something like, we're just noodling on ambiguity. And he pointed out that we have both reducible ambiguity and irreducible ambiguity, where like reducible ambiguity is stuff that you can get around by just asking follow-up questions to the people that are to the prompt that's given. So like if you ask something like, give me an analysis, you can say, what kind of analysis? But of course, like then eventually you get to a point where you're like, build me a funnel analysis. And the thing, there isn't really anything to say. You're just like, there's many ways to do that, but there's a lot less reducible ambiguity. But this is just to say, like, there's a lot, like the taxonomy stuff like this, there are a lot of concepts that map onto the semantic space that come these kind of emergent variables, I guess, for lack of a better phrasing. And maybe those are correct. Maybe there's something else more primitive that we can look at, even in semantic space, which we've been researching a little bit as well. I think the point is we got to figure this out. Otherwise, like we have no hope of understanding how to broach the topic of like, is this LLM doing any good? Like, is this answering questions well? Not to mention, there's all sorts of interesting things we could. Sorry, I'm going to go off on my like streak now. But Tara, in statistical mechanics, the interesting thing isn't that you could describe the heat and the energy. You could build a fucking like Carnot engine, right? Yeah. And then talk about like upper limits of efficiency for engines operating at different.
Yeah. So is there a Carnot engine equivalent in this thing that makes like an idealized version of what the system should act like, and then compare it to like the Carnot engine of the agentic analytics space? Yeah, I totally agree. Like we have to think about it from that perspective, but I think it is lost to all the folks that we talk to. Perhaps you need this level of precision to describe all the stuff that we're doing, because I think the reductive catchphrase right now is, oh, you put a semantic layer and put an LLM, and then you're done. Everything is golden. Thank you. At least we don't think so, because we've been doing our research. But who knows?
Yeah, that's right. It'll be fun. It's been fun, right?
It's been fun.
Cool.
Okay. With all that pontification aside, I think we've talked enough about agentic software and how agentic analytics is different. And I think why we need to construct all the headless software from scratch. GUI is bad. Natural language is good. Physics analogies are good. Taxonomy is good.
Yep.
We need precise vocabulary to understand what's happening. And just going from Newtonian mechanics to statistical mechanics, definitely need new abstractions to understand the complex systems. New abstractions, new words, new ways of thinking. And that's why it makes this job very interesting. And this type of building this product an insanely intellectually rewarding journey.
Well said.
Cool. All right, Robert. I think we'll wrap up for today.
Good.
Okay.
All right. Thanks, everybody.
Thanks.